Hello, everyone, and welcome to today's panel on the state of recycling in 2024 for energy storage and charging. Today, we're joined with some great panelists. Dev Shibambaram, PhD professor and Nevada Regions researcher at the University of Nevada, Reno. Carlos Vicen, CEO of Full Circle Lithium, and Corrado de Gasparis, CEO and chairman of Comstock. Now, this is a live event, so we encourage you to ask questions in the chat, which can be found in the bottom right corner of your screen right there. Please feel to ask away, and I'll try my best to integrate them into the conversation. But let's get started with introductions. Gentlemen, please introduce yourselves by providing a quick 1 to 2 minute overview explaining why you're joining a panel to discuss the recycling of energy storage and charging in 2024. Corrado, why don't we start with you?
Sure. Thanks, Cal. It's a pleasure to be here. So I've spent, I think, the substantial majority of my career in the renewing and recycling of electrification products. So I started my career taking petroleum coke and recycling it into synthetic graphite, then using that graphite to recycle steel in an electric arc furnace. And you know, as electrification is now really moving from heavy industry into the mainstream, you know, with EVs and with solar panels and with all these electrification products, we see two implications. One is landfills being overwhelmed by these waste materials, impacting the environment negatively. And then secondly, the absolute and desperate need for more of these materials as it continues to grow. So Comstock is sitting squarely, you know, in those supply chains, and it was a pleasure to be asked to participate today. Thank you.
And thank you for joining us today. Carlos, why don't we go with you next? And you're just on mute, by the way.
Of course. Thank you, Kyle, for the introduction. And Full Circle Lithium is I would say, a fully integrated processor and manufacturer of lithium products. We are focused on lithium and battery materials reintegration. And what we do have as assets, we have a lithium carbonate plant in the state of Georgia in a town called Nehanta, which is very close to the border with Florida. And we have 3 distinct business lines that feed this plant. One would be Midstream Recycling, which is a business that focuses on recycling lithium from waste material, either from industrial and chemical waste. The next business item, which is the one we'll be talking about today, is the battery recycling efforts, and we'll talk a lot more about that. And the third one will be our lithium refinery business, which is everything that is not recycling in terms of where our business is focused, meaning that we work with upstream assets in order for them to process raw material into saleable lithium products, as well as any other endeavor within the refinery and processing business in the lithium space.
Thank you. And Dev?
Thank you, Kyle. I'm Dev Shibambaram. I'm a professor of chemical and materials engineering at the University of Nevada, Reno. It's not Nevada. I try to correct people who say that.
I'm Canadian.
I'm the only faculty in the state with an actual degree in electrochemical engineering. And we created the batteries minor at the University of Nevada, Reno to train the workforce. I was the one who designed that, and I still offer the batteries course. On the other side, we are also Nevada has the ingredients to be a world leader in lithium loop, the lithium cycle, all the way from the mineral extraction, refining, usage, and the recycling part of it. And so for that, we were just awarded the NSF engines. I'm a co-PA on that and the tech lead, and the Tech Hub's EDA, Department of Commerce Tech Hub designation that we are getting towards for a full phase 2 proposal in a month. And I'm trying to help Nevada become a leader in the space.
Thank you. And I think your pedigree deserves a lot more of an elaboration, Dev. If you could actually just continue educating us on your accomplishments, both in general and for the discussion at hand.
Okay. All right. So let's start with my education. As an electrochemical engineering, that is a very unique and a niche topic. and one that we're actually seeing in the country right now, that there is not a trained workforce that is required at the level that is required for every company, every business to hire in this space. So my main thing as an educator is to help develop that workforce at the university. My second hat is on the research side, to help Nevada become a leader. So in this, that's where we have created. So for the education, as I said, we have created a batteries minor, a sustainability minor. But on the research side, we have been working we have a NASA-funded project. We have been working to develop a high-capacity lithium-ion battery at low temperatures, because NASA needs it at low temperatures. Right now, we have developed something that works at minus 30 degrees Celsius at a capacity that is about twice the commercial EV battery capacity. It is undergoing the patent protection, and one of the student who has been working on it, a doctoral student, he's actually on this call, Jason. He is just waiting for this patent thing to go through so he can defend and graduate and go out and do bigger things. We set up the batteries lab, and we have been pretty much working with all the battery companies because we have the materials characterization suite. We created something for industry to use that through something called the Nevada Center for Applied Research and Materials Characterization Nevada. So pretty much all the battery companies in the space in the region are using those tools to analyze, to characterize their materials, to characterize their processes. Now, the next part is, how do we take this to the next step? So in this case, that's where the NS of engines comes in, and we propose that we have the ingredients, we have the minerals, we have the mining companies, and we have Tesla Gigafactory 20 miles from here utilizing that. And now the recycling companies, including Comstock, Redwood, they're all in the vicinity. So we need to be the leader that does this entire cycling, the whole circle for lithium. And so that's what we propose for the NS of engines. We are one of the 44 that got selected for the type 1, and we are getting towards the type 2. And simultaneously, we also applied for the Department of Commerce to get the designation. We are one of the 31 to get that, who are the only ones who are allowed to apply for the next phase 2 to create this economy. And that's what we are working on right now.
I have to ask, because what caught my ear was the battery for outer space, minus 30. I'm in Canada here, and it gets to minus 39 at my parents' house. So very interested. I don't know what you can and cannot disclose on that, but like any of the metal makeup, I'd love to hear more about that.
Sure. I cannot give you specifics, but we identified where the glitches were in the regular cells, right? So NASA wants it to work at minus 60. That is their ideal goal, because they're sending it on their Mars rover and space shuttle that's going outside. How do you use it? Even if you can bring it to minus 30, you can use a little bit of a heater if this still maintains the capacity to bring it to temperature. The EV battery is a completely different one. We start off with lithium ion with graphite, and people have been sticking with that, and pretty similar electrolytes. And so NASA's work has always been on the low temperature side. And when we reviewed the literature, we came up with that, saying that those are the only guys who are doing it. So we published the paper as a review, and that's where we got the information. Okay, these are some of the things that we need to actually move forward using the electrolyte changes, the electrode changes. So we incorporated that separately, one at a time, and then both of them together, and that's where we are right now. Jason still believes that there's a lot more room to improve, and I told him that is true, and he can do that once he graduates and goes out for the bigger prize rather than at the university as a student. He has proven himself as a PhD student.
Excellent. Before I bring the other two gentlemen into the conversation, just one more question. You've been a researcher and an educator for quite some time. How has we have people on the panel with solar panel recycling and EV and battery lithium recycling. How much has this industry evolved since you started?
Significantly. We did not have this industry 5 years ago. People aren't even talking about this, right? I remember in 2019, I submitted a proposal to the Department of Energy on recycling lithium-ion batteries. And then it came back saying that, sorry, that is currently, it's not a program that funds that. And 2021, our then governor Sisolak visited the lab, and I gave him a quick white paper on this. And now everybody's talking about it. There are companies moving in, and so the awareness has come in. But I still think that we are in the very, very, very initial stages of this. That is for the battery. The solar panel recycling, it's a completely different issue. Most of them are coming out of service now from the early 2000 era that were put into place with a 20-year warranty. The cadmium telluride-based thin film solar panels, the first solar at least has some kind of contract saying that you can return it back to them. But that's not the case with the other silicon-based solar panels. It is so cheap, the material. How do you recycle this and economically and get it back in? They're piling up, and there are companies that are starting to do this. It is not an easy, simple process. And at the end of the day, for the solar panel, they're going to come up with something that has to be economically viable with the glass. But for the battery side, there's quite a few more companies, especially with the bipartisan infrastructure law bill that put in hundreds of millions of dollars into this. And there have been several technologies. The first one was, if you think about it, it's, let's burn the thing and let's refine it and pyroprocessing and get that out. We are going to be emitting some of the fumes, that's okay, but we know that technology really well. We can do that. To now, it's most of the cases, what can we get out of it at environmentally friendly levels? Can lithium be extracted economically? Pretty much most of the recycle companies are looking at cobalt and nickel, which are the most expensive metals, and therefore the lithium is an add-on that's not going to, if you were to ask a company just to recycle lithium, now that lithium prices have fallen so much, I don't know how economical those processes are going to be without the nickel and cobalt. Because nickel and cobalt, here's the catch-22, have been expensive, companies have been moving away from nickel and cobalt. So now we are going to be getting batteries without the nickel and cobalt that needs to be recycled, without the economics that is promoted by the nickel and cobalt. And so we are looking at, everyone is looking at processes that can make this really viable and at scale. So there could be things that can happen in a laboratory research like ours that may never scale up. And so that's a critical part that we need to keep in mind. What is scalable, what is achievable, and what is practical in terms of what technologies we are betting on.
Very interesting. Very interesting. Thank you. We'll go with Gerardo here. Dev posed a couple of the challenges with solar panel recycling. Why don't you highlight from what I understand, and let me see in my notes here, I had Gerardo, Comstock has Comstock Mining, Fuels, and Metals. Comstock Metals is the solar panel recycling part of the operation portfolio, right? Can you provide an overview of the circular process you're advocating? What exactly you're extracting from the old panels?
Absolutely. Yeah. So in 2019, we invested in some technology that really took initially the black mass coming from recycled lithium-ion batteries into precursor cathode active materials. And then we developed the front end of the process to crush, condition, and separate those materials. And I'll tell you what was really pesky was a lot of the laminates in the cells and the plastics in the battery packs. So we were finding that we were producing reasonably good quality materials, but that the laminates were sort of preventing us from getting all the way to battery grade, which is what we really need to do, which I think is the critical success factor for the recyclers. In that process, to your point, we realized that, the lithium-ion batteries were extending their lives. They were also working on secondary lives, and for sure, it's going to be a huge critical market for sure. But immediately, solar panels were starting to overwhelm communities and landfills, and especially in the southwest region of the United States. So states like Nevada, Arizona, California have most or the substantial majority of the deployed panels or farms, and almost 100,000 tons of end-of-life panels came out of the market last year. But staggeringly, they're projecting it to be 1 million tons by 2030. I mean, so to answer your question, well, first of all, we identified a technology and integrated it to deal with these laminates and plastics. And in the process of doing that, we brought in some new leadership that really had a lot of experience in not only recycling these materials, but eliminating safely these laminates and plastics. And so now we're starting up production, and the number one value is keeping them out of the landfills, and that manifests itself by being paid, I would say handsomely, a tipping fee to take these materials. But then we do crush, condition, and separate the materials. And we get silver in not large quantities, but it's very valuable. Cadmium in substantial quantities. It's toxic, if disposed of improperly. And then steel, aluminum, copper, and silica. The beauty of our process is in the conditioning and separating process, we're able to reuse all of these materials. So, but the revenue piece that's associated with the recovery of those materials is probably only 15 or 20% of the total, because the revenue we get from tipping fees is very robust, and we're doing good. So we're keeping them out of landfills. So we believe it's an immediate market. We believe it's critical to be deployed, and we also believe it will prepare us, downstream for other electrification products. Because in the other electrification products, be it fuel cells or be it, of course, lithium-ion batteries, there's other hazards that come with transportation and that come with storage that we don't really feel with the solar panel startup.
Great. Thank you for that overview. Really appreciate it. Carlos, I want to bring you into the conversation now. Full Circle Lithium was newly listed. It came to market last year. Can you talk about the journey of starting this company? I know there are a few companies looking at recycling batteries. I don't know how many are focused on lithium, but what sets Full Circle apart?
Sure. So, like Dev said, it's not an easy endeavor to recycle lithium from lithium-ion batteries. In fact, the name lithium-ion batteries should be, well, you're recycling the lithium and potentially the other minerals, but it's the other way around. You're recycling everything that's not lithium. And that's what's happening in the industry. And let me start by saying that I'm way beyond, the devs of the world in terms of knowledge, the intricacy of the, the operating of the batteries and all the, I would say the engineering side of things. But I look at things, and I try to look at things more simplistic through the eyes of the guys that finance the business. And that's my job, putting people that are smarter than me together to make things work. So to that end, our business is processing and manufacturing lithium products. And our main focus is lithium. We have a plant that produces lithium carbonate that can produce from either lithium chloride or lithium sulfate. And then from there, we need to find feedstock. And one of the feedstocks is, of course, the battery recycling business, which we're talking about today. But the good thing, where the market is today, is that we also have two other businesses. One is the recycling of waste material from chemical industrial companies that contain lithium, and we need to clean that out, process it in a way that's obviously doable to produce lithium carbonate battery grade or at the level that the client needs it to be. And then the refinery business as well, that we can process, I would say, raw material into lithium carbonate, either technical or battery grade, depending on what the client wants. Now, on the recycling side, the battery recycling side, I believe, and we're fairly new to the industry, like you said. We made up the company maybe 1.5 years ago. We went public last year. Many different aspects of our company are changing and evolving depending on where the market is. And if you see lithium going down 70–80% in price, you see nickel going down 50% in price. Cobalt is down 50% in price. I believe, depending on how you evaluate the graphite, which you don't even recover, they burn it, is down 30%. Copper, it's maintained because it's more an industrial product, but it's also down. So the industry, in terms of economics, you have to be really smart in how you do things, and you got to think about it differently. I think Dev and Corrado mentioned a couple of these things in their conversation where it's not easy. So you got to think about it differently. A lot of the recycling efforts that have been done so far in the battery and lithium-ion battery came from the typical recycling process in the general batteries, which is crush, grind, melt, and put it in a furnace and recover whatever it is. Not really clean. So we've thought about it a bit differently. We can't really talk about the intrinsics of it, but we're essentially taking apart the battery. We're not crushing it. We're not going through that process, and trying to recover as much as we can in all materials, specifically lithium, because that's our core understanding. Now, what we've done there is that we've in our company we've created what we call a fire suppressant solution that we can take apart batteries fully charged, meaning that we can recover a lot of the lithium compounds within the battery easier and safer in order to recover that in solution, which is what our process does. Now, independent of that, and Corrado alluded to this, in the, I guess in the solar panel side of things, you get a tipping fee. In the battery, you don't get anything. I believe that as this industry evolves, like Dev was saying, we're in the initial stages, I do believe that there's going to have to be some sort of tipping fee for recycling of batteries, because the margins are not there. The technology is almost there, but not there yet. Depending on the size of the battery, depending on what type of battery, if it's industrial, if it's LFP or NMC or NCA, all these types of batteries will have potentially different ways of processing them, potentially, maybe not. We'll see how that evolves. But at the end of the day, this black mass, as everybody talks about, which seems to be this mythical thing out there, and it's all different, because the black mass that goes to Corrado is going to be, I don't know, 50% different from what I get. And let's say we had the same process. Well, it's not going to work. It's not going to work. So you need to make sure that if you're I would say, getting the batteries and doing your own black mass is one thing. You can control to a certain extent how you do things, but I don't believe that is the way you should do all batteries. I don't think the black mass situation or the way you process some of these batteries have to be through black mass, depending on the size of the battery and all these things and the compounds within the battery. I know I threw out a lot of kind of information out there, but that's what we're trying to do. Simplistically, it's not easy, but at the end of the day, I agree with what Dev and Corrado have said, that it's starting. There's been a lot of successes along the way and a lot of failures. I foresee a lot more failures as well and successes along the way. And usually you don't want to be the first out of the gate. You try to a certain extent, Dev has done that with the batteries and the NASA thing. But I mean, when you're doing an industrial product and an industrial way that has to be large and efficient, you're going to have to take a little bit of good from other players in order to make it better. And, that's the way we see it. But we're trying to do bottoms up, where our focus is lithium, and we want to recover as much lithium as we can. That means that when we do that, it's going to be much easier for us to recover the other products too. But we want to make sure that we recover the lithium, because we need that for what we intend to do in our own company going forward. So I'll stop there.
No, you said a lot of interesting things, and the thread I want to pull on is the tipping fees. So is this currently solar panels, there's a tipping fee, EVs, no. Is the tipping fee on the consumer, the person buying the solar panel on the EV? Is it at the front end when you're making the purchase? Like, we're at a weird part in the industry where EVs are a little too expensive for people's price point. It's an interesting discussion to have. So I'll leave it open to the group on this.
I can answer just for the photovoltaics, right? So because they're end of life and because there's no secondary use, they have to pay to have them disposed of safely in landfills. And so that means the solar farms, the companies, and or the person who owns a home that's having their panels replaced on their roofs, they have to pay for them. Just like when you get new tires on your car, You have to pay for someone to take them away and dispose of them properly. And so really, and when we think of competition, we're technically competing against the landfills, but logistics is the second variable. So you might have to pay $500, $600 a ton to have somebody dispose of this material. But depending on where it's going, you might have to pay $100, $200, $300 a ton to get it there. So we're strategically locating our facilities, northern Nevada, southern Nevada, northern Arizona, southern Arizona. Why are we lining the California border? Because all the panels are in California, Arizona, and Nevada, and California has made it illegal to send these things to landfills, which we think is very smart. So they're all flooding east. It's funny to say they're coming east to Nevada, but that's what's happening, right? So, and I also want to compliment Carlos because I think, you said it too, Kyle, that being first is not necessarily best, right? I got to tell you, like, our view has always been, and it sounds like what Carlos is saying, is if you could make battery grade lithiums, if you could make battery grade materials, if you could make quality anything, trust me that the market's going to be there to buy them, right? If you rush, right, to deploy capital with processes and that overspend that don't work, you're going to be in trouble. And I don't know why you would necessarily do that, So the market's growing fast enough. The materials are needed that if you can produce good quality, especially in North America, there isn't even a supply chain, you're going to have customers. So quality and getting it right, I think, is the first step, right? Then growing it exponentially will follow.
If anyone else has further comment.
Yeah, I will add on to that. Based on both what Corrado and Carlos said, one of the things that Carlos hit upon was this black mass, right? In the investment community, that's like a mutual fund. Put everything in there. We don't know which one is a better one, right? But within that, there'll be a few stocks that are really good. If you can take that out, so it's a hedge your bets. Let's put everything in there, and then a batch to a different batch of black mass is going to be very different. And the industry is now starting to recognize some of these issues, and we are actually looking at a longer part of how does the industry regulate itself to make the recycling and the materials available. Right? One of the things that you're hearing a lot about is modular batteries on EVs. So it's easier to swap them out and take them out. Currently, if there is an accident on an EV car, many of the insurance companies will total it because they don't want to fix that. There's no real infrastructure to fix a battery on an EV car that is in there right now. If it's modular, you can take that out. You can swap the battery out, and if some of the batteries have really died soon, you can take them out in Canada, put in a different battery pack. That also has the logistics of knowing what the batteries are. If the companies can code them into what is the elements in there, right? That makes it easier. So Redwood Materials is working with Tesla to take their batteries that is not meeting specs. This is coming right off the manufacturing line. It is not meeting specs. They know exactly the chemistry. It's a lot easier to recycle those compared to somebody puts in 20 different batteries from 20 different manufacturers with all kinds of additives, minerals in there that you don't know, and that comes up as a black mass. And that process is not going to be viable. So thinking about those kind of things and how it can be modular, how it can apply to a particular kind of battery. Now we are going more into lithium iron phosphate. There is no nickel. There is no cobalt. How do you make this economically fully viable? That's the part that Carlos was saying about the tipping fees. Even lead acid batteries, when we get one in the store for your starter battery, you pay $15 to $35 fee that they refund you. So they want to make sure that is not ending up in the landfills. There has to be some kind of regulations and tipping fees like that to make this ensure that this supply chain and this battery parts are safe and are handled properly.
Interesting stuff.
Yeah, and I think, I mean, just to add a little bit to that, I think, you know, looking at it just pure financially, right? You know, I see some of these investments in CapEx that when I look at the economics, and Corrado alluded to this, it just, for the life of me, I just don't see this ever going to generate any returns from shareholders. And, you know, when I say shareholders, it could be us three here, us four here putting money, but it's the institutions that really have the money. So, you know, a lot, at least on the battery recycling side, let's just talk because that's what we're talking, not any other business. One company that does something wrong, independent of how they did it, just because they were first out and they just tried their best, but you know, it affects all of us. I really root for everybody because at the end of the day, if they succeed, we are going to succeed in that grand scheme, in the sense that it pulls us up. It doesn't pull us down. But as you know, as any nascent industry can allude to that, you're going to have failures, and it's pulling us down. At the same time, by the way, that all these material prices are going down, and the capital market, whatever, I mean, the U.S. market, I don't know how the U.S. market goes up, but in our industry, our junior industry, we're going down, and there's less eyeballs on juniors and I would say entrepreneurs and startup companies that are trying to get through through this maze. So it's very hard for us to do it. Now, I mean, and I'm going to throw a little bit of kind of full circle advertisement here, but what we're trying to do to mitigate the fact that there is no tipping fee and there is no, to a certain extent, help from the government available ASAP, is that we utilize the materials that we recycle internally for some of the other processes. So if we wouldn't be recycling batteries, we would have to go out and buy certain of these materials out there. So it's not as cheap. So for us, it makes sense to recycle some of these batteries and recycle some of these materials and then reuse them in our either absorbent when we do some of the processing and extraction of lithium from solution, and or when we do our fire suppressant solution, some of these materials go in there as well. And that fire suppressant solution not only helps us recycle batteries, but also hopefully once we do all the relevant studies, it also will help with all the fire issues and concerns that are surround the lithium-ion battery, which, you know, hopefully our solution is there to mitigate some of that risk. I think that type of ingenuity from not only us but others has to happen to survive in this market. Because if you're just plugging along doing hydro or pyro or a combination of the two and putting billions of dollars to work, good luck, because not everybody can partner up with Tesla, right? I mean, there's obviously the gentleman that runs Redwood is an ex-Tesla employee. They understand each other well. I hope that they succeed, but the amount of money they're talking about for me is just outrageous in terms of CapEx. But, you know, you can partner up with other types of companies and move this forward, I guess, in the nascent stages until things kind of start working. So I just wanted to add that too, because tipping fees are going to be important. I don't know how fast that's going to happen. And then you get regulations of shipment and logistics, which are enormous through states, and you're shipping this thing. So it doesn't get any easier.
No, great. I'm going to transition to the public markets based off that, Carlos. Like you alluded, if one succeeds in the industry, it's such a niche industry that many people feel the uplift, it goes the opposite way too. If one struggles, maybe it puts a black eye on the industry. What is the key struggles the industry is facing? And on top of that, for these retail speculators, investors that they see this movement and this transition, what do you look for in these companies? Is it patents and partnerships, or what are we looking for?
Is that question to me or to Corrado, or to, I don't know?
Open to the group. Feel free to kick it off.
Go ahead, Corrado. I already spoke, so you can.
Just to start it, you could pick it up after. But, you know, one of the things I do hear in what Carlos is saying, which I think is very wise, is, you know, if you're working, you know, working with, you know, partners, working with, you know, some suppliers, some customers, establishing yourself, right? Getting the process to be effective. It's safer. The market's dynamic. We can certainly, one thing we can predict is how unpredictable, right? The commodity prices, the efficacy of the supply chains, they're just being established. So there's a lot of dynamic. You could use the word volatility if you want, right? It's petrifying, right? It's just scary. So establish yourself with some counterparties, right? Start getting the cycle going and working. I think it's very important. Don't get ahead of yourself, right? Establish a quality solution. Again, one thing I think we're certain of is the demand will be there for quality solutions. And then third, the logistics of it all. He mentioned hazardous, transporting and storing hazardous materials. It's very expensive with a downside, right? So establishing, good, safe logistics, including how you handle and manage. And I would be more concerned about the quality and stability of those processes versus the speed at which you're growing them, because I think the market will pull you. It's going to be a demand pull here, right? But you have to establish a quality system that can then respond to that demand.
Carlos, did you have any further thing to comment on?
Well, I look at it more, I guess, more pragmatic, and you see this in gold and silver and copper in terms of, how things happen there. And look, I mean, what's the problem with the industry? CapEx, OpEx. I mean, you're saying things that you don't understand, or you're saying that it's going to be $1 billion, but it's really $2 billion, and the CapEx creeps up every single time. So I would say that, before you run a marathon, you better make sure that you can run 5K or even less than that. But usually what we want to do is that we want to do this extraordinary news release that says we're going to produce 50,000 tons of lithium carbonate by the end of the year. It's like, well, I mean, there are no operations in the world that are 50,000 tons. So you're going to tell me that as a startup, you're going to do 50,000 tons? Well, I don't believe that. And people now are understanding the lithium market and the battery materials market a little bit better. That includes our shareholders, and that's institutional and retail. So they're going to call your bluff a lot of these times. So look, CapEx is running up, OpEx is running up, pricing is volatile, and it's going to continue to be volatile. So you're going to see the margins compress and expand, and depending on where you hit them, you may be lucky and be able to finance a business, where you may be dead in the water because you hit one of these downturns and nobody wants you, which is what a lot of the things are happening right now. So the diversification of business is a good thing. Going smaller rather than larger and proving it out as small is also a good thing. And then people, right? I mean, I'm not dev. I don't understand all the relevant information and data and all the, I would say, the engineering side of things when you look at the battery. But I know the market, so I'm a people kind of a CEO, so I hire the people to run this. So, that's the way to build a business. You can't have all technical people, because usually these technical people is just heads down and do their good job, but they don't see the market. But you can't see all market and no technical people, because then what is it that you're doing? I mean, it's all a lie. So it's a good combination of both things. So on the people side, and then also on how you progress through your, your business wise. I think that's a problem, and that's what I see. And when things are good, and it always happens in gold and silver and copper and everything, tons of projects come up, right? Oh, it's like mushrooms in the morning, and where they grow almost. How is it that we had maybe 4 or 5 or 6 lithium recycling companies, and all of a sudden we have, I don't know, 50? That's because the market was really good, frothy for a while, 12 months ago or 18 months ago, and all these guys came up. But now you're going to see some of these disappear, merge, and which is a good thing. I mean, yeah, you purge these as you go forward. So my 2 cents, that's what I wanted to say on why I think there's, the problems that are occurring in the industry right now.
And I'll add on to those two, Corrado's and Carlos's points. Carlos actually touched on this a little bit earlier as well. You know, there are so many companies that come in and say, oh, we are going to do a hydro, and then we're going to recycle. If you now take up all the recycling companies, how much they'll be recycling in 2026, 2027, it's always 2 years projected out, right? We don't have that many cars by 2030 to recycle. All these companies that they're saying that they will recycle that much of the material. We have to look at, and I have assessed a couple of, as a, before the chat started, I was mentioning to you about my family background. I've assessed a couple of companies in what kind of a technology is this? Is this something that we will invest in, right? Lithium America, it's a good story that they found the largest lithium deposit. They're coming up. But now see what has happened is that other companies are getting lease from BLM and saying that, oh, we have the lease on this land. There's lithium available. If you dig any land, you're going to find some level of lithium somewhere, right? But is it economically extractable? And that's where the data comes in. You have to go in and look at that and say, okay, these companies that are now showing up with saying that they can mine lithium from this land, I don't think that they can economically do it. The concentrations are so low, or they don't have the process yet, because one clay is not the same kind of another clay. Each one has to be individually developed. So similarly, the batteries, the technology has to be developed, and the technology has to be assessed, whether one, it is viable, two, is it unique enough, and three, is it commercial value? I mean, is it scalable? Sometimes they're not scalable. And so people can assess these to see, which ones are the ones that you're willing to bet on in the longer term.
Now, Deb, well, I know a few of you gentlemen have meetings soon, so I want to wrap up. And typically, when I wrap up, I let the companies do a little pitch. What can we look forward to in 2024? But Deb, I want to start with you, and I'm going to phrase the question this way, because you're an educator here, and I feel like a lot of retail investors, they might be younger people that might be looking at a career change. Where can they go to get education in this space? And just for the people that are doing due diligence in the space, where are good outlets? So feel free to talk about your university or wherever, but if you know of any reputable courses online or what have you, please feel free to help the audience.
Thank you, actually. I'm actually proud to say that UNR started the first batteries miner in the country. And we created the first batteries course at the undergraduate level. The students go through a complete lab starting from raw materials, powders, to making the batteries, testing them to failure, understanding that part of it. I can recollect a conversation where one of the battery manufacturers came in, they were looking for recruiting, and they asked, oh, do your students have any glove box training? I was like, glove box? I mean, they're doing the whole batteries. They go, oh, most of the students do not have the training to work in a glove box. That's important for us. So even simpler things or that are important are not available in most of the regular education, right? Nowadays, a bachelor's degree gives you something, but you do need a little bit more advanced degree to specialize if you're interested in batteries. And you do need to find groups and universities that are doing this. A lot of the universities are coming on board because they're seeing this huge government push in terms of funding and in terms of education. So they're coming on, but the ones that started a little bit earlier have a little bit more of an edge. And it's not just at the master's PhD level. You also have to go down at the community college levels, because the workforce required for all these companies, it's not just at the highest level, it is at all the levels. So we are working with our partner sister institution, the Truckee Meadows Community College, and the other community colleges in the state. 6 of us are part of this NSF engines. They're part of the tech hubs, trying to develop courses, trying to develop these certificate programs that people can take. Even working professionals who want a career change, they can do a graduate renewable energy certificate program through UNR, get some level of background going into this online course. So the educational thing is going to improve. One of the things, the branding, many times when you say chemical engineering, it's not the same thing. Materials, people don't understand what that is. And that needs to get out to the public so students and potential students can understand what they're interested in. The current generation is highly, highly motivated to work in the climate change space, however they can help. And it is our duty as an educator to give them those opportunities. And we need to work with companies to provide them internships so that they see a pathway and the companies see a pathway to attract this talent force and keep them with the country here.
Excellent. I love that. Corrado, we will go with you now for Comstock. What can people expect for 2024? Just some closing remarks.
Yeah, absolutely. So we've started securing across the spectrum. It's funny, our customers are our suppliers, right? So with the tipping fee model, our suppliers is a critical part of the equation. So we've started securing quite rapidly supplies. Trucks of solar panels are rolling in. Even before we were ready to take them. We're waiting for one last permit. We're expecting it within the next few weeks, which means commissioning in February and production starting up in March. And then we literally want to have 3 or 4 facilities over the next 2 to 3 years, as I said, along the California border. So quite exciting in terms of ramp up and growth. In the meantime, as we ensure the quality of the existing system, we'll start to experiment with other electrification products, batteries. Our black mass is a funny term. We produce gray mass with our solar panels, and we would produce white mass with hydrogen fuel cells, black mass from lithium-ion batteries. So hopefully, ultimately, we'll expand out. But we're with Carlos. Like we want to walk before we can run.
Excellent, thank you. And Carlos?
This time I did take my mute mode off. So what we're focused on all our business models. We've already refurbished our entire plant and is operating, but our first, I would say, hopefully claim to fame would be to put our first commercial plant on the midstream recycling industry, which we're recycling, I would say, waste material from one chemical company in the U.S. We have 2 others on the go that hopefully we get these term sheets and binding agreements signed over the next few months and weeks, and work towards getting not only one client, but several clients this year and into next year, and ramping up the tonnage of recycled material, lithium material that we're producing on the midstream recycling. On the battery recycling, we are still going through some of the tests, like Corrado is saying, we're walking before we're running, but we have created significant volume of batteries that we're going through and analyzing, and we already have significant amount of gallons of product that we'll put through our lithium carbonate plant and recover some of the material, and that's going to happen the first half of this year. The FSS, which is the fire suppressant solution that came from our battery recycling business, it's also very important for us. So you will see some news to that this year in regards to how we're going to partner and try to market that solution into the broader supply chain, and that has many different types of usages. And in fact, we talked, Kyle, back a month ago or so, weeks ago, about this specific, so people can see some of that video. And then the rest of our refinery side is we're focusing also on raw material. We talked a little bit about the way that some of these mining companies are popping up, and some are real, some are not real. And if you have a resource but you can't extract it, process it into a sellable product, there's no value on that resource, right? So a lot of these technologies need to be tested in some of these resources. Not one technology is good for every single project. And we're working with several projects, not only in North America, but also in South America. And we intend to give some of those results over the next, I would say, 1 or 2 quarters. So all our businesses are kind of trying to move forward in this market. Obviously, it's not the best market to be in, tell you the truth, but we foresee that all the battery material metals, because of the fact that the inventory is going down and the fact that we're seeing cuts in production, and many of the producers, we're going to see a rebound in pricing in a very short term.
Thank you, Carlos, and thank you all for participating today. Really appreciate it, and for everyone that attended. If you did come in a little late, this event is being recorded and will be available on YouTube, so you can feel free to watch it again. But gentlemen, thank you so much for the great conversation.
Thank you
very much.